Hello, boys and girls. All right, we're on chapter 6, lesson 4, common denominators. Woohoo! Okay, we've talked about this word common a couple times, right, guys? Common. Like, what do you have in common with your best friend? What do you have alike? What do you like to go to the movies? Do you like Star Wars? Do you both have just 4 toes on your left foot? You know. That is something you might have in common. That would be weird and interesting. And then what's the denominator? It's the bottom number of the fraction, right? Numerator is the top, denominator is the bottom. One of my friends said D for down, right? Denominator, D for down, it's the bottom number. Okay. So when you're finding a common denominator, you're trying to find a denominator that both fractions could have. A denominator both fractions possibly could have. Okay? So let's jump in here to number 5. A denominator that's the same, of course. What I always look at first, okay, is, oh, you know what? I'm going to pause. Let's read the directions because I cut the directions off here. So this is number 5 and 6. The directions say, write the pair of fractions as a pair of fractions with a common denominator. Okay, so I'm going to have to write these fractions again, but they both have to have the same denominator. So 2/4 and 7/8. I'm going to rewrite them with equivalent fractions that have the same denominator. The first thing you should do is say to yourself, is one of these denominators a factor of the other one? In other words, can I multiply one of these numbers by something to get the other number? Remember factors in the factory? Those are the building numbers in the factory, right? So can I multiply 4 by anything to get 8 from the factory? Yes, of course. You guys know that, right? So let's look at 2/4. I can definitely make 2/4 an equivalent fraction with 8 in the denominator because 4 is a factor of 8. 4 times what is 8, guys? You already know. Times 2. 2 times 2 is 4. Remember, whatever you do to the numerator, you have to do to the denominator, or vice versa. Okay? So I'm going to rewrite these fractions. 4/8, right? 2/4 is equivalent to 4/8. And then what do I have to do to 7/8? Nothing. It already has 8 as a denominator. That's why you should always think, is one of these denominators a factor of the other one? Because look, we only had to deal with one of these fractions. We were like, oh, 7/8, you're fine. You already have 8 in the denominator. Let's go to number 6. Okay? What did I just say? Look at the denominators and think, is one of these a factor of the other? Well, look at that. 3 is a factor of 12, isn't it, guys? Right? So if 3 is a factor in the factory, right, in there with 4, I think, ooh, I'm going to cross that out. I can't even read it. 3 times something can get me 12. A factor. So I know that 2/3 can be a fraction that's equivalent to something that has 12 in the denominator. 3 times what's 12? 4. Okay. What do I have to do to this 2, boys and girls? Multiply by, yes, by 4. Okay. So 2/3 is equivalent to 8/12. And then look at this beauty. 5/12. I just have to write it down again because we were looking for a common denominator. So I cannot emphasize that enough. I want you to always think, is one of these a factor of the other? Because you're really cutting your work in half, aren't you guys? Let's keep going. All right. These people love these problems, don't they? Equivalent or not equivalent. But we are going to think about common denominator here. So 6/8, 3/4. Is one of those denominators a factor of the other? Well, let's see, when I think about 4. Is 4 a factor of 8? Count by 4s. 4, 8, oh, bing, it is. So let's make 3/4 a fraction with 8 in the denominator. Now, what do I do, guys? How did I get from 4 to 8? I multiplied it by 2. So what do I do up here? Multiply it by 2. Okay, so 3/4 is equivalent to 6/8. Oh, so 6/8 is equivalent to 3/4. All right, let's try another one. Great work so far, guys. 3/4 compared to 2/3. Let's see here. Let's think along the lines of common denominator. But I also want you to notice these fractions are both 1 away from a whole thing. So are they going to be equivalent? I just want you to think about that. I bet you can already figure it out. Okay, is 3/4 equivalent to 2/3? Well, if you can see beyond my horrible diagrams. Okay, well, we're going to find a common denominator though. Okay, I want you to think of, first of all, 4 and 3. Is one of those a factor of the other? Is 4 times anything 3? No. Is 3 times some number going to get you 4? No. Okay, so let's list some multiples. Because when we list the multiples, we know a number that they can both be multiplied to get to. No, wait, I have to reverse that. We know a number that they can both get multiplied by something to get to. So we're going to find a number that 3 times something will get to it, and 4 times something will get to it. All right, so let's see. 3, 6, 9. I'm writing my multiples. Remember, multiply that number times 1, times 2, times 3, right? Do you see a common multiple? I see it too, right there, 12. So we're going to make 3/4 a fraction. Oh goodness, I have a space situation here, don't I? All right, I'm going to draw it right here. 3/4 a fraction that has 12 in the denominator. And I'm also going to make 2/3 a fraction with 12 in the denominator. 12 is our common denominator. Okay, so 4 times what is 12? Times 3. 1, 2, 3. So what am I going to do to that 3? Also multiply it by 3. Okay, so now we know that 3/4 is equivalent to 9/12. Let's try 2/3 now. So I want 3 to go to 12. I know I can get there by multiplying, right? Times 4. 1, 2, 3, 4. Excellent. What do I do to that 2, boys and girls? You got it. Multiply it by 4. 8. So 2/3 is equivalent to 8/12. So now you're thinking, is 8/12 equivalent? I mean 9/12. Goodness gracious. Is 9/12 equivalent to 8/12? Of course not. Bah. All right. Beautiful work. Did you know that when you did this? Some of you might have known, since they're both one piece away from the whole, they are not going to be equivalent. All right, let's look at number 14. We are comparing 2/10 to 4/5. Okay. What's the first question again? Look at those denominators. Is one of those a factor of the other? Yes, right? I know that 5 is a factor of 10. So I know that 4/5 can be an equivalent fraction that has 10 in the denominator. And because there's my beautiful 10 right there, right? What am I thinking? 5 times 2 is 10. What do I do to that 4? Multiply it by 2. 4 times 2 is 8. Okay? So I know that 4/5 is equivalent to 8/10. Is 2/10 equivalent to 8/10? No way. No way. And you know what, guys? If you and your good fraction sense looked at these without just focusing in on denominator, you would have known they weren't equivalent. 2/10, that's way less than half. And 4/5, that's almost a whole thing. Okay? Always a good way to look at fractions too, just what you know about fractions, because you're so smart. All right, here we go. Problem solving. Down at the bottom. Adam drew 2 same size rectangles and divided them into the same number of equal parts. Okay, got it. He shaded 1/3 of one rectangle and 1/4 of the other rectangle. What is the least number of parts into which both rectangles could be divided? Are you thinking what I'm thinking? I'm like, what? What are they talking about? Well, let's think here. He had 2 identical rectangles. He shaded 1/3 of one of them and 1/4 of the other one. Okay, but don't forget, they were divided into the same number of equal parts. So like one of them wasn't just divided into thirds, and one of them wasn't just divided into fourths. They were divided into the same number of equal parts. So what is the least number of parts into which both rectangles could be divided? So I want to think about 1/3 and 1/4. They could both be fractions that have which denominator in common? If we think of a denominator that they have in common, that means that my rectangle could be divided into 1/3. And my rectangle could also be divided into 1/4 with that same number of equal parts. A common denominator, a common number of equal parts that both of these rectangles are divided into. Okay? I bet you already know this, right? So if you need to, you can think of multiples of 3 and multiples of 4. Because a common denominator is like a common multiple. We need to find something that I'm going to be able to multiply 3 by and get the same as when I multiply 4 times it. Okay, so let's do 3, 6, 9, 12. Okay, and then 4, 8, 12, 16. Do you see the common multiple or the common denominator? Yes. We're going to have rectangles that are both divided into 12 equal parts. Okay? So 3 times what is 12? 4. What do I do up here? You got it. 4 times what is 12? You got it. Right? So what is the least number of parts into which both rectangles could be divided? They're not asking for these fractions, are they? They are asking for the number of parts in which both were divided into, or the least common multiple, least common denominator, 12 parts. All right, excellent. Let's keep going. All right, we are on the back on the lesson check. This is number 1. Which of the following is a common denominator of 1/4 and 5/6? Okay, so 4 and 6. Now, a least common denominator is the same as a multiple. Okay, remember that you multiply that 4 and that 6 by something to get the same number. All right, let's just look at our choices. Can I multiply 4 and get 8? Oh, sure. 4 times 2 is 8. Can I multiply 6 times something to get 8? 6 times 1 is 6. 6 times 2 is 12. We just passed right over you, 8. What about 9? 4 times 2 is 8. No, 4 times nothing is 9, right? And 6 times 9. You don't fit either one of those. Okay? How about 12? Is 4 times some number 12? 4, 8, 12. Oh yeah, 4 times 3 is 12. So 12 is a multiple of 4. Is 12 a multiple of 6? 6, 12. Yeah, and you could have done the list. Okay? Totally done the list of multiples. Okay, that's up to you guys. There it is though, right? Ding, ding, ding. 12's been a popular number on this homework page. 12's so popular. 12, let's hang out with you. Okay, and then let's just look at 15. No, 15. 4 times nothing's 15. 6 times nothing's 15. Okay? All right, good job. Now we are on the fab review section. This is from chapter 4, lesson 11. On a bulletin board, the principal, Ms. Gomez, put 115 photos of the 4th grade students in her school. She put the photos in 5 equal rows. How many photos did she put in each row? Want to reread? Yeah, let's go back and take a look at that. So what is Ms. Gomez doing? She had 115 photos. She put the photos in 5 equal rows. How many were in each row? Okay, I'm feeling it now. Are you guys? Right? So she's got the bulletin board. She's got 5 rows. How many go in each row? Okay, what do we have to do? Put your hands out for 115. 115! You have all these photos, and you are separating them or sharing them or distributing them into 5 equal rows or parts. Okay? We're going to be doing, what is that when you're sharing, separating equally? Division. Okay? It's good practice. Okay, let's do say 5 to 1, right? No. How about 5 into 11? Yep, 2 times, right? Now, are you remembering our does McDonald's serve cheeseburgers, right? So let's go back. The first thing Mrs. Olvey did was divide. Here's my division. 5 goes into 11 2 times. Multiply. 2 times 5 is 10. Subtract. Boop. Check. Is 1 less than 5? It sure is. And what's our B for? Bring down. Okay? And start all over again. Okay? D for divide. Divide 15 divided by 5. Oh, you know that basic fact is 3. Multiply 3 times 5. 3 times 5 is 15. S for subtract. Oh, look at that. I subtracted all the way down to 0 already, didn't I? 23. Excellent job. Really, really excellent job, guys. It's always good to go back and practice these skills. And if you did this a different way, if you did partial quotients, awesome. You could have used the distributive property. You could have broken apart 15 into 100 plus 15 and done it that way. Awesome. Okay, but everybody should have gotten 23. Lots of ways to do it, though. Have a great night. See you soon.